Hello class. Okay, so we are now down to the last conic section. Okay, so we are done with parabola. We are also done with ellipse. Okay, we now proceed with hyperbola. Okay, now before we proceed with the definition of a hyperbola, let us recall first the property or the definition of the parabola and the ellipse. Now take note class, for a parabola, we have here a fixed point, the focus of the parabola. We also have here the fixed line or the directrix of the parabola. And take note, based on the definition, the distance from any point of the parabola going to the focus is the same as or equal to the distance from that same point to the directrix. So if you have here the point P, this is point P class. Therefore, this one, the distance from F to P, is the same as the distance from P to, you have a point here, part of the directrix. This is your point Q. These lines or these line segments are of equal length. Okay? For an ellipse, if you can still recall class, if you have a point here, point P, okay, the sum of the distances from the fixed points to the point class of the Cartesian of the ellipse. For this one, we have P going to F1, okay, plus P going to F2, okay. This one is constant, meaning if I pick another point of the ellipse class, for example, this is point Q, so therefore Q going to F1 plus the distance from Q to F2 will be the same as the previous na sum. In other words, PF1 plus PF2 is equal to QF1 plus QF2. Okay, those are the definitions of the parabola and the ellipse. Let's now proceed with the definition of the hyperbola. Okay, so a hyperbola class is the set of all points on the plane. So again, we are considering here coordinates of the Cartesian plane. The absolute value of the difference of whose distances from two fixed points is a constant. Still, the fixed points referred here are the focus or the foci of the hyperbola. Now, in this case, class, for example, take a look, these are the points of the hyperbola. If you have here point P, if this one is point P, based on the definition, class, the absolute value, so you have the absolute value of the difference between the distances from this point going to the focus or to the foci. So if you have this one, P going to F1, okay, the distance from P to F1, denoted by this, and then the difference, so it's minus the distance of the same point going to the other focus class. So it's P going to F2. So the distance from P to F2, according to the definition of the hyperbola, this must be constant. Now, ano yung meaning kung constant siya? If I pick another point class, point Q here, this is point Q, and I'll follow the same process akong ibuhat kanina, I'll take the distance from Q to F1. This, okay, again, it's the absolute value of the difference of the distances from Q going to F1, distance from Q to F1, and from Q going to F2. So minus Q to F2. Since this one is constant, this is also constant. Therefore, this one, this difference class, must be equal to this difference for any point of the hyperbola. So, meaning, pag nalang po kani class, kani siya minus kani will be the same as kani minus kani. Again, just take the absolute value so that we can assure class, we are assured na positive sila tanan. Okay? So that's the definition of the hyperbola. Again, any point of the hyperbola, this one going to F1 minus this one going to F2. Again, minus. Ang sa ellipse sa una class, that's PF1 plus PF2 is equal to a constant value. Okay? Again, the constant values here, class, are denoted by the same letters. We still have A, B, and then C. Okay, so you'll see that one in the examples. Okay, we have here the comparison between the standard equations of the ellipse and the hyperbola. So if you can see here, class, they are almost the same. Okay? So let us now see unsay difference nilang duwa silang standard equations. Now for the ellipse, class, we have here the graph, the equation x minus h squared over a squared plus y minus k squared over b squared is equal to 1. Now take note, the graph of this ellipse is something nagahigda. Okay? And its counterpart sa hyperbola, class, is this one. It's almost the same. We still have this one, this expression, but the positive here, class, becomes negative in the hyperbola. And still we have this one equal to 1. Still, a squared here is the denominator of x squared, just like in ellipse. Okay? For the second standard equation, again, they are almost the same, class. Again, the positive here becomes negative in the hyperbola. Now, take note, class, for an ellipse, the only way para mabalaan if unsa ang form sa ato ang graph is the number or the denominator a squared or the bigger denominator. Kung asa ang bigger denominator naa ba kay x or naa ba kay y. Now take note, if ang bigger denominator is na kay x, gahigda ang ato ang ellipse. And if a squared or the bigger denominator is na kay y, gatindog ang atong ellipse. But for this one, class, for a hyperbola, a squared will not be always greater than b squared. Okay? So, walay comparison si a squared o si b squared. Now, how do we know if gahigda siya or gatindog ang atong hyperbola? Now, it will depend on kinsa ang naka-positive. Okay? If ang naka-positive dali, class, is ang x, therefore ang atong graph or the hyperbola will open to the left and to the right. And for this one, since ang naka-positive, class, kani negative man eh. So, ang naka-positive is si y. So, therefore, ang atong graph is something that opens upward or downward. Now, for this one, class, for a hyperbola, kung kinsa ang naka-positive, class, that's automatically, or the denominator sa naka-positive will automatically become a squared. Compared to ellipse, that the bigger denominator will always be a squared. So again, as I have mentioned a while ago, a squared here could be greater than b squared, or a squared could be less than b squared. Again, there is no comparison between a squared and b squared. Now you can see it here in the equation. For an ellipse, we have here the formula c squared is equal to a squared minus b squared. And in this case again, a squared will be greater than b squared, and a squared will also be greater than c squared. But for a hyperbola, class, we have here the formula c squared is equal to a squared plus b squared. Now clearly, in this case, c squared will be always greater than a squared. C squared will always be greater than b squared. Okay, so that's the difference between the ellipse and the hyperbola. So again, if ang naka-positive nga sign, in this case, ang naka-positive is ang variable x, so the graph of the hyperbola looks like this one. Okay, so it opens to the left, and rather to the right, okay, at the same time. And then for this one, if ang naka-positive is si y, okay, again, regardless kung bigger ba si a or si b, now the graph looks something like this one, or the hyperbola, class, opens both upward and downward. So again, class, we have to take note that for a hyperbola, c will always be greater than a. Also, c will also be greater than b. That's for a hyperbola. Okay? So now, just like the ellipse, class, the distance from the center with coordinates hk, again, hk here could easily be found on the standard equation of the hyperbola. The distance from the center to the vertex v1 here, or center to v2 here, will still be equal to a. The distance from c to f here, or the center to the focus, will still be equal to c. And the distance from the center going to the endpoint class will still be equal to b. Okay, again, exactly the same with the variables that we have used in the ellipse. Now, take note class, for an ellipse, the line segment joining V1 and V2. Take note again, this is for ellipse. The line segment joining V1 and V2, from V1 to V2, is what we call the major axis, while the line segment joining E1 and E2 is what we call the minor axis. Now for hyperbola class, almost the same concept, but we have a different term for each class. This time for hyperbola, the line segment connecting V1 and V2 here is not anymore the major axis. Okay? We cannot call it the major axis again, class, because since there is no comparison between a squared and b squared. So a could be greater than b, a could be less than b, and sometimes a could be equal to b. So that's why it is possible, class, that the minor axis for an ellipse will now be longer compared to the major axis. So for this one, for a hyperbola, we call the line segment from V1 to V2 as the transverse axis. Okay? Again, it's called the transverse axis. And now, the line segment joining E1 and E2 for a hyperbola, this is what we call the conjugate axis. Again, conjugate axis. For the spelling class, you may refer to your book. That's on page 27. Okay, those are the terms, class, that are new for a hyperbola. Now, okay, let us consider this example, class. You're given with 16x squared minus 9y squared is equal to 144. Okay, so first thing it will do is to change this one into its standard form. So take note, in the standard form, the other side must be equal to 1. So just like what we did in ellipse, we just have to divide both sides by 144. Okay, again, divide by 144. So after dividing, the other side will now be equal to 1. For this one, we now have 16x squared divided by 144. It's the same as x squared over 9. And then 9, okay, I have here minus. So 9y squared over 144, this becomes y squared over 16. Okay, so we now have x squared over 9 minus y squared over 16 is equal to 1. This is now the standard equation of our ellipse. Now again, take note, class, since ang naka-positive diri is ang variable na x squared, therefore, ang forma sa atong graph is something na, the hyperbola opens both sa left and sa right. Okay? And take note from our previous discussion that katong naka-positive, class, or the denominator sa naka-positive, automatically, ang denominator niya will be equal to a squared. So, a squared will be equal to 9. Again, you might wonder, class, nga, hala, nga a squared man na, smaller man si 9 compared kay 16. So again, kanang idea is applicable lang for ellipse. For a hyperbola, class, again, the positive here, the positive nga term, or the denominator sa positive nga term, will always be a squared. Okay? So therefore, kato naka-negative derivative, this will be our b squared. So there is no comparison between a squared and b squared. Okay, again, for a hyperbola, the bigger variable will always be c squared. So therefore, we have here a squared is equal to 9. This means that a is equal to 3. And then, b squared is equal to 16. Thus, b is equal to 4. Okay, using the formula for c squared, we have c squared is equal to a squared plus b squared. So therefore, we now have a squared is 9 plus b squared, which is 16. We now have 9 plus 16 is 25. And, okay, this is now your c squared. Therefore, c is equal to 5. Okay? We have A, B, and C here. Again, all we have to do, class, is to count. The same as what we did sa ellipse. We just have to plot the center, and then knowing that the hyperbola here opens the left and to the right, so you just have to use the variables A, B, C to move and to determine, class, the vertices, the foci, and the endpoints of the conjugate axis. Okay? From here, class, take note, this is just the same as x minus 0 squared. This is also y minus 0 squared. So therefore, our center will be at 0, 0. H 0, and then k is 0. Okay? Okay, so we have here A, B, and C. And then for the first property, our center is at the origin, 0, 0. So again, we plot the center, class. This is now your center, 0, 0. So we write here C, the label by the letter C. And then next is, we need to use the value of A here, which is equal to 3, to determine the vertices of the hyperbola. And take note, class, since the hyperbola opens to the left and to the right, so our vertices must be on the left and the right side of the center. So from the center, we count 3 units, class. We have 1, 2, and 3. So this is now your V1. Okay, another 3 units to the right. We have 1, 2, 3. This is now your V2. This point is now your V2. Okay? And then next, we use the variable B, which is equal to 4, to identify or to find, class, the endpoints of the conjugate axis. Okay? So since our ellipse opens to the left and to the right, our endpoints of the minor axis of the conjugate axis must be located upward and downward of the center. Okay, so we need to count 4 units from the center. So you have 1, 2, 3, and 4. This is now your E1. This is now your 4. So you have E2. By the way, I forgot to write here our V1 here, the coordinates of V1 we have, this is -3 and then 0. And then the coordinates of V2 we have this one, it's 3, +3, and then 0. And for letter C, the endpoints of the conjugate axis, our E1 here has coordinates, this is 1, 2, 3, 4. So we have 0 and then 4. And then our E2 has coordinates, we have 0 and then -4. Okay? That's 0, class. Next property, letter D. We need to use the variable C. Just like in ellipse, class, C here is the distance from the center to the focus. Okay, so I'll just count 5 units left and right from the center. So we have 1, 2, 3, 4, and then 5. So we have here, this is now your F1. And then 1, 2, 3, 4, 5. This is now your F2. Okay? Next. So again, A here is equal to 3. B is equal to 4, C is equal to 5, and our center is at 0, 0. So we first plot the center, 0, 0, into the Cartesian plane. So we have here, this is now 0, 0. So it's C, or the center of the hyperbola. Next, we locate the vertices of the hyperbola, class. But take note, class, since our hyperbola opens to the left and to the right, therefore the vertices must be located on the left and the right side of the center. So from the center, we'll have to use the variable A here. We'll move 3 units going to the left and to the right. So from the center here, we count 1, 2, 3. This is now, okay, this is 3 units away from the center. This is now your V1. Okay, V1 here has coordinates -3 and then 0. Okay, next, move 3 units to the right. So we have 1, 2, 3. This is now your V2. Okay, clearly the coordinates of V2 here, class, we have 3 and then 0. Next, so letter C class, we need to find the endpoints of the conjugate axis. So just like the ellipse, we'll use the variable C here. We move 4 units up and down from the center. So we have 1, 2, 3, 4. This is now your E1. E1 here has coordinates 0 and then 4. For E2, we'll move 4 units down. So you have 1, 2, 3, 4. So this is now your E2. Okay, the coordinates of E2 here, it's clearly 0 and then negative 4. Next, we find the foci. So we move from the center, we'll use the variable C. C here is 5. So we have 1, 2, 3, 4, 5. This is now your F1. F1 here is coordinates negative 5 and then 0. Then on the other side, we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is now your F2. So again, the coordinates of F2 here, we have 5 and then 0. Okay? For letter E, just like the ellipse class, we have the equation of the major axis. So since we don't have a major axis here, our major axis here is called the transverse axis. So the transverse axis again is the line segment which passes through the vertices. Okay, the line segment connecting the vertices. This is now your transverse axis, and this line segment class is along the x-axis. So since it's along the x-axis, the equation will be y equal to 0. So this is now the equation of the transverse axis. Again, this is just the same as the major axis in the ellipse before. Okay? For letter F, we find the directrices. The directrices of the ellipse. But take note, class, the directrices of the ellipse is the same as, okay, the distance from the center to the directrix class is the same as sa ellipse before. Okay? Still, we have the formula a squared over c. So from here, this is equal to a squared, which is 9, and then over 5, which is the variable c. So 9 over 5 here, so 9 divided by 5 is 1.8. So I'll move 1.8 units from the center going to the left and to the right side. So we have 1 here and then 0.8. So from 1.8, I'll make a line. So this is now the one of the directrices. The other one is on the right side. So 1.8. So this line. So this line is now the directrix class, one of the directrices. Okay, the question is, what will be the equations of these directrices? So the same thing as what we did sa ellipse class, since we are moving to the left and to the right, we just simply add a squared over c, or 9 over 5, or 1.8 to h here. Okay, so since it's vertical, so the equation will be x equal to the variable h. H here is 0, and then plus minus here indicates the lines sa left side and sa right side. So plus minus a squared over c, which is 9 over 5. Okay, so therefore the first one, this is now the equation x equal to the negative of 9 over 5, and then this one, the right side, this is the positive, so x equal to positive 9 over 5. By the way, I forgot to write the equation of the line of the transverse axis y equal to 0 here. This is the your y equal to 0. And then finally, we have here E, or the eccentricity. Same formula, class, it's just C over A. So C over A here is C is 5, and then A is 3. So clearly, class, 5 over 3 is greater than 1. If you can still recall from a theorem in our previous discussion, the eccentricity of the hyperbola will always be greater than 1. Okay, next. So we have already plotted class all the necessary mga properties sa ato ang hyperbola. So, saan di siya pag-form sa ato ang hyperbola? Take that we have here the vertices. So, ang atong buhatan class is this. We make vertical lines and parallel lines or line segments rather that passes through the vertices and the endpoints. So, consider this one, V1, V2, E1, and E2. So, from these 4 na mga points class, we will make a rectangle. Okay? This is what we call the auxiliary rectangle. Again, this is what we call the auxiliary rectangle. Saan? So, magbuhat ta og line segment passing through B1. Kani? Taman lang kay E1. Ginapunta kay E1. Kani? Ginapunta kay B2. Paingon kay endpoint na po diri. And then, this is now your line segment. Passing B1. Okay. Kani siya class, if you can see. Kani siya. Kani, and kani. It's now a rectangle. Now, unsay purpose anang rectangle diha? So, from this rectangle class, we will make asymptotes. If you could still recall, unsa ang asymptotes gani? Diba, these are lines wherein ang atong graph kay almost magkaduol. Okay, but it will never touch the line or the asymptote. Okay, so saan pag-form sa asymptote? So, we consider the vertices of the auxiliary rectangle class. So, we just have to connect the vertices or the opposite vertices of the auxiliary rectangle and also passing through the center. So, we have this one. This line. Kita broken lines, no? So, passing through the vertices. And then, this one. Okay? Another one. Ito na pong pikas ng side. So, nanaputi another nga line here. Another asymptote passing through the vertices, passing through the center, and to the other nga vertex class, to the opposite nga vertex. So, these are our diagonal na mga asymptotes. Now, unsay purpose asymptotes? So, we just make class a parabola sa left side and sa right side. We start from the vertex class and then we make a parabola nga almost lang mo-touch sa atong mga asymptotes. So, from here, may mo na siya. Okay, from here, from the vertex, buhatag something curve na almost maigo sa ato ang asymptote. And on the other side as well, buhat lag ka og parabola, curve. So, you have this one. Okay? This is now the ellipse or rather, the hyperbola that opens to the left. On the other side, the same thing class. We connect the vertex. Okay, we start from the vertex and then we make a curve that almost touches the asymptote. And also on the other side, downward, ups. So you have this one. Okay. So this one class and this one is the curve that almost touches the asymptote, and also on the other side, downward, ups. So you have this one. Okay, so this one class and this one is the graph of the equation x equals the asymptote, and also on the other side, downward, ups. So you have this one. Okay, so this one class and this one is the graph of the equation x squared. For second example class, we are given here with the general equation of the hyperbola. So first aim before we find the properties, we just have to convert this one into its standard form. Now take note, the process of finding its standard form will be exactly the same as what we did sa tuang ellipse before. Okay? So the same thing, dili parehas gyapon og coefficients ang x squared ug y squared, so dito pwede mag-divide both sides. So what we'll do then will be ang atong i-combine lang class or ang atong ipang-group ang katong mga same variables. And then for 29 here, ato lang siya i-transpose to the other side. So may mali siya og 9x squared, and then together with this, minus 18x, and then plus, we have this one, negative 4y squared, and then this, minus 16y is equal to negative 29. Okay, after this, ato i-factor out katong mga coefficients atong x squared o y squared. So from here, with this becomes 9 times x squared minus 2x, and then kani siya ma-factor sa negative 4, may aning minus 4 times y squared. So ang negative 16y class, i-factor nimo ang negative 4, mabili na lang diri will be positive 4y equal to negative 29. Okay, this time, naka-1 na ang coefficient ng x squared and y squared. So we can now proceed with completing the square. So we have 9 times, unsa may i-add sa x squared minus 2x para mag-perfect square. Okay, so we add here plus 1. And then minus 4. And then say i-add sa y squared plus 4y para mahimong perfect square. So we add here plus 4. Equal to negative 29. So take note before sa to ang ellipse, natin i-add pa diri. And ang atong i-add diri class will not just simply be 1 and 4. It will be 9 times 1 and negative 4 times 4. So from here we have 9 times 1, so we have plus 9. And then negative 4 times positive 4. This is equal to negative 16. Okay, do not be confused ha, ano negative na siya again because of the negative 4 here. Okay, so we now have 9 times x minus 1 squared, and then minus 4 times y plus 2 squared is equal to, this one is equal to negative 36. Okay, so take note para ma-standard equation sa class, kailangan naka-1 ang other side. So we divide by negative 36 divided by negative 36. So this is now equal to 1. So diri, what will happen here? Kaninga part class. So this will be x minus 1 squared over 9 over negative 36. Sa mabilin diri si negative 4. And then this one, y plus 2 squared. So, negative 4 over negative 36. So, may mo siyang positive. Okay, over positive 9. Okay. So, para mahimo pagit siyang standard equation class, the same thing as what I have given you a while ago. So, ato na siyang i-transfer din yung side para ang positive ang maguna. So, we now have y plus 2 squared. Again, transfer this one here over 9. And then simply copy this one. So, we have here minus x minus 1 squared over 4, which is equal to 1. This is now the standard equation of this hyperbola. Okay, any question class so far? Okay, so we now have here the standard equation of the ellipse. So again, our a squared here is equal to 9, or a squared is 9. We have here b squared is equal to 4. So thus, a is equal to 3 and b is equal to 2. And to solve for c, we have a formula. C squared is equal to a squared plus b squared. So it's now a squared is 9 and then b squared is 4. So our c squared will be equal to 13. So therefore, c is equal to square root of 13. Okay? So we have A, B, and C here. So we now have the following properties. We start with the center. The center here, take note class, kaning 2 diri is not H. Okay? Since kauban siya ni Y, therefore this will be our K. Our H here, or our center will be at, from this one, X minus H, we have 1, and from here we have negative 2. So center at 1, negative 2. So we plot 1, negative 2 here in the Cartesian plane. So we have 1 here and negative 2. So this is our center. So this is the center of the hyperbola. Okay, next, letter B. Now take note class, by the way, aga open ang ato ang hyperbola. Okay? So since ang naka-positive diri class is ang variable nga y. So therefore atong hyperbola must open dito sa taas o diri sa ubos sa ato ang center. Okay? So therefore, to find the vertex class or the vertices, kailangan nun tayo move og 3 units up and down from the center. So we have here 1, 2, and then 3. This one is now V1. And then the coordinates of V1, it's clearly 1 and then 1. So we have 1, 1. And our V2 class, 3 units down from the center. So we have 1, 2, 3. So we have this point. This is now V2. And the coordinates of V2 class, we have 1 ang iyang x. And then 1, 2, 3, 4, 5. Negative 5. So we have here the vertices. Next, we have the endpoints of the conjugate axis. We use the variable b. So we move 2 units from the center. Okay? So we have 1, 2 here. So this is now your E1 with coordinates. This is now negative 1 and negative 2. So E1, negative 1, negative 2. And then our E2 class, 2 units sa right side. So you have 1, 2. This is now this is E2. With coordinates, clearly from the graph class, the coordinates of E2 are 3 and negative 2. Okay? Next, letter D. We find the foci. We use C equal to square root of 13. Square root of 13 class is approximately 3 point something. Okay, 3 point something. Move lang ta. So from here, 1, 2, 3 point something. So assuming mo na siya. This is now your F1. And what will be the coordinates of F1? So take note, ang x class is the same as H. So we have F1, coordinates 1. Ganun sa man pagkuha sa iyahang y. Unsa man diri nga part class ng y. Now take note from the variable k, or this is our k, di ba? K is negative 2. Nag-move ta pa sa ka or nag-add ta og square root of 13. So this is now k, which is negative 2. Nag-add ta og square root of 13. Okay? And our F2 class, mag-subtract ta kay k, or from the center, mag-subtract ta og square root of 13. So it's 3 point something again. So we have 1, 2, 3 point something. So this is F2. What will be the coordinates of F2? Same lang x. 1. And then ang k, which is negative 2. Kuhaan lang para manaog ta og square root of 13. Next class. The equation of our transverse axis. Again, the transverse axis is the line segment passing through V1, V2. But the line segment is along the bigger line, which is kani. This is now your transverse axis, or let's just write this one class. Kani. This is now your transverse axis. Okay, the equation. My last class. So this is your transverse axis. So the equation of this one, it's vertical. So it's x equal to, again, there is C1. So it's x equal to 1. Letter F. We find the directrices. So again, applying the formula class, a squared over c. A squared is 9 over c, which is square root of 13. Rationalize, this is 9 square root of 13 over 13. And in decimal, this is 2.5. Okay, 2.50. This is 2.50. So 2.50. So mag-move lang ta from the center of 2.50. So we have 1 and then 2.50. So we have here our directrix. Can class? Unsa may iyang equation? Na take note ang iyang equation class gikan kay k, gikan kay center nag-move ta og kaning 9 squared or 2.50 units up. So nag-add ta kay k og 2.50. So this one is horizontal. Kumain mo na siya x equal to this will be y equal to the value of k, which is negative 2. And then nag-add ta og a squared over c, which is 9. This one. So the other directrix class, move ka punta 2.5 pa down. So you have 1, 2, and 0.50. So you have this one. So this is now y equal to, same thing, negative 2, but it's now minus 9 square root of 13 over 30. Okay, and lastly, okay, by the way, from here we have y equals, so negative 2 and then plus minus this one. Letter E. E is for, okay, letter A, B, C, letter G, sorry. Letter G. This one is for the eccentricity. C over A. C over A, so you have square root of 13 over 3. So clearly this is greater than 1. Okay. So na-plot na tanan, we now have the properties. Ang atong buhaton is katong auxiliary rectangle. So again, we make a rectangle class passing through V1, V2, E1, and E2. So we have here V1, V2, E1, E2. So magbuhat ang rectangle. And this. And this one. And then we have this. And then we have this one class. Okay, so this is now our auxiliary rectangle. Okay, we have here the vertices of the auxiliary rectangle. And then again, after the auxiliary rectangle, we make the asymptotes, the lines, diagonal lines. We connect this one class. So it is. We have here the vertices of the auxiliary rectangle. And then again, after the auxiliary rectangle, we make the asymptotes, the lines, diagonal lines. We connect this one class. So it is. It should pass through the center. And this, oops. Wait class, wait, sorry. So it's something like this one. Okay. Another one, kaya pambigas. These are our asymptotes. So again, the asymptotes here will help us kung unsa ka buka ang ato ang ellipse. Okay, from the vertex class, magbuhat ang parabola nga ma-approach sa ato ang asymptote. So we have this one. Another one here. Okay, and sa ubos we have from the vertex, Oops. And it's because... Okay. So this is now the graph of the hyperbola. Take note, class. Ang part sa hyperbola is kanila. Kani and kani. All the other nga mga portions sa class, the points, the broken lines, they will just help you para ma-form ang imuhang hyperbola. Okay? Any question? Any clarification? Okay? So, para mas makasabot. Okay, so we are done with the examples. So, kindly try to answer this one in your regular notebook. So, practice problems. Okay, try if you have really understood the discussion. Okay, you are given here with the general equations. So, just convert these equations into their standard forms and then find the properties and afterwards sketch the graph of the hyperbola. Okay, so I hope you have understood everything, and then if you have any questions, i-reserve na na class while I reserve na lang sa class. Okay, so thank you for listening.